Welcome back to my channel. Friends, in this session we will see this PNP Darlington transistor. It is power transistor for 10 ampere 60 to 80 volt. Unlike to a simple transistor, it have some special structure that is inside this transistor, that it have one signal transistor, power transistor, recovery diode, and it have two biasing resistors for the base biasing. How we can check with multimeter, and then we will check it practically by applying power. If we want to test it with multimeter, its test is slightly different with compared to a simple transistor, simple power transistor. How it is different? When we want to test it, we have two transistors here, 1 and 2. If we check this one, base to collector, it will be tested as a normal transistor. And if we see its pin out, 2N6667 667 base collector emitter. The metallic tab is also collector. If you see here 1, 2, 3, 4, so it is TO220 package, base emitter collector. Set multimeter to diode mode. The leftmost pin, that is base, and it is PNP. That means base is N, negative. We will connect black lead to the base, and we will connect red lead to the collector. It will give a forward diode drop voltage for one diode. It is 0.587. So we are testing base to collector. Let's reverse the leads at the same places. It is open. Now we will test from collector to emitter. Collector, we have recovery diode. Normally we will connect emitter to collector any one direction. For example, I want to connect black lead at collector, red lead at emitter. It is open. Why? Because this junction, collector to emitter junction, it is open. If the transistor is good, it will give open circuit. Now reverse the leads. Black lead at emitter, red lead at collector. We are testing this diode. Black lead at emitter, that means it is connected to cathode. Red lead at collector, so we are testing this diode. When we are testing in this way, that black lead was here, at that time the diode was reverse bias and the junction was open, so it was open. But now when we have red lead here, black lead here, black is at cathode, red at anode, it is forward bias. Now we have emitter to base junction. Base to collector we tested. Now we want to test this. As we know, in any junction, when we test with this multimeter, it will give 250k resistor for one junction. Let me demonstrate. At base, when we will connect black lead at a base, red lead at collector, it is 584 millivolt. Let's move to ohms. 259 kilo ohms. If we see the structure now, if we will test base to emitter, we have one emitter to base junction, the second emitter to base junction. We cannot test two junctions at once because it needs these positive voltage to operate this base. But if we will test base to emitter, we have up to 8 kilo ohm resistor from this base to emitter and 120 ohm between this power stage. So maximum 8 kilo ohm resistor will be there. 256 kilo ohm here, 8 kilo ohm there. When two resistors are in parallel, the total resistance will less than this one. So maximum resistance can be 8 kilo ohm and 120 ohm. let's check the resistance between base to emitter. It is 788 ohms, 0.786 kilo ohm. Reverse the lead. We said 8 kilo ohm maximum. If it is from 800 ohms to 1 kilo ohm, 2 kilo ohm, up to 8 kilo ohms, it is acceptable. Okay, now this is the test. If we get short circuit from emitter to base 0 ohm, 1 ohm, 2 ohm, that means internal structure is damaged. Base to collector short circuit, damaged. Collector to emitter short circuit, damaged. If we don't find resistance between base to emitter, that means this resistor set is damaged. Now we will apply power to test it practically. I will place on the project board and I will take two resistors to be connected at collector and emitter. It is 54.6 ohm, 54 ohms. The same second one I will connect at emitter. The second resistor at collector. One resistor at collector, one resistor at emitter. And I will use a potentiometer. It is 50K stereo potentiometer in two portions. So I will connect in parallel. So it will become 25 kilo ohms. We can place at any point. Okay, I will place it separately. Collector will be supplied with negative voltage because it is PNP. So negative at collector. Negative voltage we will provide to the potentiometer one side. And positive voltage will be supplied to the emitter and we will connect it one side of the potentiometer. The center node of the potentiometer, the slider arm, we will connect to base. Because this transistor, it have a signal amplifier here inside the transistor, inside the package. So it will sense the weak signal and it will switch. I will use 10 volt signal to test it. Negative voltage to the collector resistor, positive voltage to the emitter resistor, and we will connect multimeter across this collector load. The circuit configuration is now one resistor, second resistor, negative voltage, positive voltage, and we are connecting this positive voltage minus 10 volt here, and we will tape this signal and we will connect here. Let's start. This time there are no voltage on multimeter across this top side resistor. Why? Where are the voltage now? Because the transistor is now open and the total voltage are dropped across the transistor junction. Yes, the total voltage are across the transistor junction. And if we check the emitter resistance, no voltage across emitter. Okay, we will connect across the emitter resistance, and now we will adjust the voltage from this potentiometer and we will see (20 millivolt), 2.6 volt. This time the transistor is now in conduction phase. It is now started to conduct. 2.9 volt at this resistor. If we will check the second resistor, (2.8 volt here, and if you will check the transistor junction, 4 volt are dropped across the transistor junction. Now we are taking 2.9 volt here, 2.9 volt here, 4 volt here. So it is now in working state, in conduction state. This is not now in saturation. Let's move it to saturation state. One volt here. This time we have 1 volt at collector load. Let's check across the transistor. Now it is in saturation. It is totally 0.6 volt across the collector to emitter junction. And let's test the emitter resistor. It is 8.4 volt. 8.4, 0.6 volt for the transistor, 9 volt, and 1 volt across this collector load. So we have 10 volt now divided among all these components. 1, 2, 3. 1 volt here, 0.6 here, 8.4 here. If I will change the biasing again, the voltage, the division of the voltage will change from this resistor to junction to this resistor. So this transistor is now working good. In this way we can check the function of transistor, how it is working, how it is delivering the voltage. When it is in saturation mode, that means at that time it will work as a switch. In this range it is working as an amplifier, high gain amplifier. When it is in this condition, that the minimum voltage at collector load resistor, the maximum voltage now at emitter load, 8.44 volt. Because this time emitter current is total current, that is addition of the base current and collector current. This time the maximum voltage drop will there, and minimum voltage at collector, that is 0.6 volt, and very low drop at collector. I hope so this video is informative. If it is informative, hit the like button. If you have any question, write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.